Hi, everybody. I'm Adam Wolff. I'm an engineering director at Facebook. But today I want to talk about something I spend a lot of time thinking about, which is how we're going to build a reactive, live updating, distributed GraphQL server. Let me first illustrate kind of what we're up against with the kind of problem that we face at Facebook. So I want to write a comment-like renderer for what we call the permalink page. I tap on a status update and I want to see all the information about it. So in order to do this, I obviously need to know the original post. And then I need to get what we call the connection coming off that post for all the comments that I see there. And then I need to go another level and fetch all of the likes, which point to profiles for the people who've liked these comments. And this kind of two-hop data fetching is exactly what makes GraphQL so great and why we like to use it. But it also causes problems in the live update scenario. Let's just take a look at that. So someone comes along and likes the second comment, we add a new edge. And the problem that we have is that it's not enough just to listen to this top level, the root of our data fetching hierarchy. We also need to subscribe to all the intermediary nodes and find out what happens when they change. And this kind of problem, has never really been solved at scale in a distributed system. We can kind of imagine using Rx and observable for this kind of system, but I want to present an alternative. So I'd like to sort of think about this graph as a series of immutable updates, a log. So let me present kind of one structure that we could use to represent this graph. It's got 4 columns in it, and the first one is going to be a global time identifier. I'll talk a little bit about eventual consistency in a second, but eventual consistency is the reality in any distributed system, even though we can kind of try to gloss that over. So imagine this like an epoch time plus enough random information so that we can at least decide, looking at 2 entries in this list, what order they belong in, even if we find out about them out of order. Then we're going to have a type. These are either nodes or edges. This is a graph after all. But we can label these edges especially so that we can tell the difference between someone, say, authoring a comment and liking a comment. Then we're going to have an ID. This would probably really be like a UUID, but in this case, I'm just kind of using strings. And then we have some data associated with each one of these rows. For nodes, that's going to be a bag of properties. For edges, that's going to be more structured. It's an ID2, we call it, which is the thing that the edge points to. And then we have to remember whether adding or removing this edge because we have immutable data. We don't want to ever delete anything. We just want to append. So when we write, we're generally going to write down and add things to this table. And when we read, we're generally going to read backwards and read the most recent information first. Now, I call this sort of abstraction a stream. I wrote a little class for this, tried to write something like newsfeed, just a toy with it. It's a little cumbersome to use. I found it was a little easier to think about the different things that can appear in the stream one at a time. So let's take just the comment edges, for instance, in this stream and isolate those and call this a topic. And I call it a topic because it's similar to like an Apache Kafka topic or any of these log-based append systems that we're starting to see first used for data analytics, and I think we'll start to see them in production too. For a topic, we can have a pretty simple API. And basically, even though we are going to have eventual consistency, it's really hard to program out of time order. So we want to present developers with a time-ordered API. So we're going to have a topic. It is like a generic class over some kind of data T. The constructor, we're going to bind that type that we saw in the table to the topic there. For convenience, we'll provide an add function, although when we write, of course, we want one-way data flow. We know that from React. So that's just for convenience. And then we have this important interface that's called Memo Eyes. And the idea behind Memo Eyes is actually to produce the same kind of fake reactivity in this system that we have in React, right? Like that's what makes React so great, is that you get this kind of reactive update without having to worry about getting pushed an event that makes no sense, like delete something or change something. Really what you want to do is just get your data and render. That works super well in React, and I think we could make it work in a system like this. So for this interface, basically, I'm going to give you a function that takes an iterable over this topic. Again, I'm going to read it backwards, and produces a value. And then whenever I call the memoized version, I'll either get the last version, or if the data has changed, I'll recompute. So there are two things we need to build on top of these topics, nodes and edges. For nodes, we want two features that would be really great. One is partial writes. We don't want to have to read before we write, especially a consistent read. That would be really bad. And we also, as I said, want to support eventual consistency. So for, like, let's say we have a user profile, and the user adds their first name and last name to their profile. And then later, they update their age. You can see that I can add the age using this system without having to read the name first. The other thing is we might find out later that the user updated their name, and because of the way the topic API works, we sort of reorder these before we run our memoization function, and then we can produce like a memoized bag of properties for this node. That's pretty simple. Connections are the hard part. You know, if you think about React, this is like children getting rendered in a React tree. And we want some more fancy features here, like we want streaming tail load. So I want this ability to, like, as I scroll up, I want to load more and not load it all right when I start. I want reactive update, so if I add something at the end of the stream, that should appear there too. And then I also need memoization still, because a lot of times a connection represents a set and not an ordered list. So let's say we have a chat window, and chat's interesting because when I open a chat window, I need to go backwards in time and fetch historical data to fill the sort of up the window. But I also, of course, want to subscribe to events going forward in time. So how could this work in a system like Buzz? Well, what I'm going to do is, again, I'm going to read backwards. And when I step off the end of my list, I realize that I need to load more data. So I read again, and now I need to load more data. And maybe the system realizes that we need to page some in here. And then finally, I read, and I don't step off the end of the list. We know we have enough data. Now, the interesting thing is that we can handle reactive update almost exactly the same way. We just write to the bottom, and now we read again, and we can fill the chat window up. So hopefully you see the parallels with React. There isn't a lot of time to develop this too much further. There's just a few more things I want to say before I go. I think this is the beginning, and this is an open area that I think a lot of us are going to be working on for the next few years. Super exciting and interesting. Apps are getting more real-time, especially apps for the phone. I think we need to look more closely at broadcast-based network protocols. I think if we had realized the need for end-to-end encryption before we built networking, we might have broadcast-only networking. Like that, that's kind of my intuition about that. I also think probabilistic algorithms for distributing information, especially gossip and bias gossip, where we can sort of decide whether to transmit a message to a neighbor based on what we know about them, are really interesting. And finally, I think there are new network architectures that we can invent that will have much more better and more interesting scaling properties than what we have now. All right, that's it. Thanks a lot.